All right, let's move into slope-intercept form. So Liam has $10 in a savings account, so that's where the 10 right here is starting at, and plans to deposit an additional $5 each week. That's where this 5 is coming from. Liam wrote the equation and created the graph to show the relationship between x, the number of weeks, and y, the balance. So we're going to find the slope of the graph. Where do you see the slope in Liam's equation? The slope is 5, and it is the coefficient of the x term in the equation. So we see that slope right there. Then, where does the graph intersect the y-axis, and where do you see this in Liam's equation? The graph intersects the y-axis at 10. 10 is the constant in the equation. And you can see the constant right there. So, slope-intercept form. Slope-intercept form, or y equals mx plus b, is one way to write the equation of a linear relationship, where m represents the slope and b represents the y-intercept. You're going to use the definition of the slope-intercept form that we just did to answer the questions 1 through 4. So we're going to list the slope, which is m, and we're going to list the y-intercept, which is b. One thing I would do on this first part is list these continuously. My slope is m, my y-intercept is b. So the slope in this equation is 2.5, and the y-intercept is the b, which is 4. Again, my slope is m, my y-intercept is b. You can have no y-intercept, which means it is 0, or it crosses the origin. Again, we have our m and our b. So my slope in this part is a negative 1/7, whereas my y-intercept, my b, is 0 because it goes through the origin. My slope is m. My b is my y-intercept. Again, I'm going to label these things so I remember. It is important that we know them. My slope in this case, you can't see it, but there is an invisible 1 right there, so it's a negative 1. Whereas my y-intercept, I always pay attention to the sign to the left, so it's a negative 8. Don't forget about the sign to the left. And then again, we have our m, which is our slope, and our b, which is our y-intercept. But notice how I immediately went to what I've been used to. Our b is our constant, so it has to be our one-time amount. And our m is our slope, and it's next to the coefficient. So that's what's important here. I wanted to make sure that you paid attention to the fact that it can be flipped, and you don't want to mess that up. So my slope is 3/2. And my b, my y-intercept, is 15. It's very important to pay attention to the slope being next to the coefficient. I'm sorry, the variable, because the slope is your coefficient. We're going to write the slope-intercept form of each graph below. So I can see on this first one that my y-intercept is the easiest place to start, and my y-intercept is my b. So when my x is 0, my y value is what my b is. So x is 0, my y is my b. So my y-intercept is 18. And then doing my slope, I can do that rise over the run. So I need 2 perfect points. So I can use the slope formula that we've used, or I can rise over run. And I always do rise up or rise down. We're going to rise down, which means it's going to be a negative. I rise down 2, 4, notice what we're counting by, and I run over 1. So I rise down, which is a negative 4, over 1, and that simplifies to just a negative 4. So my slope is a negative 4. Again, you can use the slope formula for this as well. When I write my equation, it's y equals mx plus b. So y equals my slope of negative 4x plus 18, which is where it crosses the y-axis. Again, my y-intercept is right here, so when x is 0, my y is my b, so my y-intercept is 3. I can see that everything's going by 1, so to find my slope, I'm going to find 2 perfect points, and it could be any 2 perfect points. So here and here, I can see that I'm going to rise up 1, 2, 3. I'm going to run 2, 1, 2. So my rise over my run is 3 over 2. And so when I write my equation, y equals mx plus b, it would be y equals my m, which is 3 over 2x, plus b, which is my 3. Again, my y-intercept is negative 2, or sorry, 0, negative 2. So my y-intercept is a negative 2. And then my slope, I find 2 perfect points. I can see that this is perfect, this one's perfect, this one's perfect. I rise down, which is a negative 1, and I run 1, 2, 3. So my rise over my run is a negative 1 over 3. And when I write my equation, it's y equals negative 1/3 x minus 2. Notice I didn't put 2 symbols there. If it is a negative, I make it a negative. All right, in 8 through 10, we're going to plot the y-intercept, then we're going to use the slope, rise over run, to plot a second point on the graph, and then we're going to draw a line to connect. So start by going to your B, your y-intercept, so that's where the line crosses the y-axis, so this would be at a negative 4. And then I'm going to rise up to, so rise over run, and it's positive, so rise up to run over 3. And that's going to be my next point. And I'm going to go ahead and do it one more time. Rise up 2, run over 3, 1, 2, and we go off the graph right here, which is okay. And then we would connect those points. And it is continuous, so you would continuously go in both directions. All right, so next, again, we're going to start by graphing the 45, which is my y-intercept. 45 is right here, over 0, up 45. And then my slope in this case is a little different. I have my slope, which is my m, and that's your rise over your run, which is a negative 5, but there's always a 1 in the denominator, so we're going to rise down 5. In this case, because we're counting by 5s, rise down 5, run over 1, and then you can plot another point. We're going to do another one. We're going to rise down 5, because we did 40 to 35 and run over 1, and that's because of how the graph is done. And then because I did extra points, we can go ahead and stop there and make it continuous in both directions. In this next one, we can see that there is no y-intercept listed, but that means that it goes through the origin. So we're going to start at the origin. My slope is my rise over my run. And because it's a negative, I'm going to rise down 1. And run over 2. And notice how it goes by little halves here, or it goes by 2s. So you got to pay attention to that. So 1, 2. This one's a little bit harder to do because of that. So I'm going to rise down 1 and run over 2. And then now we can get that perfect point right there. And then you connect them and draw your line. All right, let's continue. We're going to write the equation in the linear relationship in slope-intercept form. We've got a table, and we've got to list the slope and the y-intercept. All right, so the easy one to start with is our b. When our x is 0, our y is our y-intercept, so that's a -3. But here I'm going to have to use slope formula, which we have learned and is on our math chart that we can use, which is y2 minus y1 over x2 minus x1. And this is something that we can continue to look at and think about. We can also graph this to see this. However, I can pick any 2 points that I want. I'm going to stay away from as many negatives as possible. This is y1, and then this is x2, y2. So now I can list y2 is 0.2 minus y1 is a -1.4 over x2, which is a 4, minus x1, which is a 2. Again, you could have used any of these points that you wanted to use. And then I do my math, so I would do 0.2 minus a -1.4, and I get 1.6 over y minus 2 is 2. When I simplify that down, I get a 0.8. And I'm going to go ahead and list that as a 0.8, just because when graphing and looking at this, it makes it a little bit easier. So my equation is y equals that mx plus b. My m is 0.8x. My b is a -3, so I write -3. Again, the easy one to do here is right here, where my x is 0, my y is my b, so my y-intercept is 35. And then I would do that slope formula again. I can use any of these points that I want. So x1, y1, x2, y2. And then I'm going to go from here and do y2 minus y1 over x2 minus x1. My y2 is 365 minus 200 over my x2, which is 6 minus 3. 365 minus 200 is going to give me 165 over 6 minus 3 is 3, and that simplifies down to 55. So my slope is 55. When I write my equation, y equals mx plus b, they're both positive, so y equals 55x plus 35. All right, let's continue. The graph shows the linear relationship between the number of minutes Ingrid has traveled and the number of miles she is from work. We're going to write an equation for the graph. So we have that y equals mx plus b, y equals mx, and then I've got to figure it out. My b is where it crosses the y-axis, which is the y-intercept. That's a positive 24, so we put plus 24. That's the point 024. And then my slope, I can see here's a perfect point, and then my next perfect point is here. So I've got to pay attention. It's going by 3. So 3, 6, 9, 12. So my rise is a -12. And then my run is also going by 3. So 3, 6, 9. And then that simplifies down to a -4/3. And it does have that negative slope. So -4/3 x plus 24. What is the rate of change and what does it represent? The -4/3 is traveling 4 miles every 3 minutes. And then what does the y-intercept, and what is the y-intercept and what does it represent? The y-intercept is 24, and that represents the start 24 miles away from work. When y is 0, what is the x value? That's going to be, what does the point represent? When y is 0, my x is 18, and then that's after 18 minutes, Ingrid has arrived at work. So a lot of this is stuff that we've already learned, but we're now going through that y and x and those main points of the y-intercept and the x-intercept and what do they represent. Make sure you ask your teacher if you have any questions.